Okay, recording got started. As I told you before, right, we can integrate our Elastic File System to our Kubernetes cluster, EKS. For that, it is not an inbuilt feature actually. We have to use some additional configuration. Means like using some particular configuration, you have to integrate your Elastic File System to your EKS cluster. So what's the benefit do I get is your data will be persistent, which means that even though my Kubernetes cluster is crashed in worst condition, even though my Kubernetes cluster has been crashed, still my data will be available in my Elastic File System. Later, if I want, I can use it. Tomorrow, I can create a new Kubernetes cluster and I can share the same data. Or that could be one scenario. Second scenario could be, let's say, I want the same data, Elastic File System data, where my production server is using. I want to use same thing in my dev environment as well. So single Elastic File System, I can share it to multiple Kubernetes clusters. Okay, that could be the second reason. And the third reason could be like, let's say that is a known thing. If you delete any pod in your Kubernetes cluster, again a new pod will be created. If it is a deployment or replica set or replication controller, stateful set, daemon set, whatever it is, the pod will be recreated. When the pod is recreated, I should not lose the data, especially application data. So in those conditions also, we use this particular Elastic File System as a better approach. So now let us see how we can integrate this Elastic File System to our EKS cluster. As you know that I will be using this Kubernetes cluster all the time. Let me just open that. Let me know if the voice is not that clear so that I will reiterate or I will respell the words. Okay. Let me create a notebook. So here, let me give the name, generic name like role. Launch template not using it. So let's say next. Let it be this default settings. Here I will be representing 3, minimum 2, maximum 4. Then this is sufficient to launch our compute nodes. Then next, I'll be launching my compute nodes on this particular subnets, and I want to SSH to it to show some particular data. So that's the reason. I will be using this particular key to log into that particular compute nodes, and I want to use all the security groups what I have in this VPC. Okay, that's the meaning of all. If you want to select specific security group, go for this option. Okay. And no, I don't want this. I am not, and I'm not sure that which security group I have to select. Go for all. Later, if you want, you can modify the parameters. Okay. Let me say next, and this is the preview. And you know that I will be using this local system to communicate to my EKS cluster. You can see there, I'm able to communicate to the nodes, Kubernetes cluster, but I don't have any nodes right now. Once this node group has been created, it will be successful. In between, if you have any questions, also you can ask me. Okay, so don't feel that you should not interrupt and all. If you're not able to understand any point, just interrupt me so that I will repeat the same topic. Okay. Now we are creating a node group for my existing EKS cluster, and this is the document what you have to follow in order to set up Elastic File System to your EKS cluster. It is called a CSI. CSI in the sense Container Storage Interface. Driver in the sense it is a plugin kind of thing. So using this particular driver, we are taking the help of Elastic File System to store the application content which is running on your Kubernetes cluster. That's how it is. So this is the diagram which we are trying to implement. Okay, maybe it is a bit complex for you to understand, but if you try to simplify this, this is the VPC network. So your control plane is running on this VPC and compute plane also is running on, it is using both the same VPC actually. Okay. Now we are using Elastic File System to integrate your nodes. Instead of Fargate, right now we are using EC2 instances. Okay. Now as a user, I'll be using load balancer to communicate to my applications. That's how it is. Even though my pods got deleted, a new pod will be created and it will mount to the same Elastic File System. That's what I need to achieve. So I should not lose the data. The ultimate goal is, even though my pod is running here and later it is running here or any other node, I should see the same content. Okay. Before the pod got deleted, what is the status? I want to continue from there. If I want that, I have to use this. Let's see. Let us try to implement this. It will take few minutes. Meanwhile, let me go to the CLI. I will just come. Okay. I think the nodes are up. Okay, we are done. So all the nodes are up. You can see the ready status. So now I have 3 complete nodes to launch my application. Before that, what we have to do, we have to integrate our Elastic file system. So let's follow the document. So always understand that we have to read the considerations. Means what you need to do. Before starting my action on this particular integration part, I have to read the points. If you don't understand this, you might be doing some mistakes. Okay, remember that clearly saying you that you have to use Elastic Driver. Is it not compatible with Windows-based container images? Let's say, unfortunately, you are using Windows containers. Let's say you have created your worker nodes as a Windows machine. Then it is not compatible. So Elastic File System is not compatible with Windows-based container images. Simple. If you have to launch your containers on Windows as a Windows containers, you can't use Elastic File System with this CSI driver. You can use only Linux containers. Okay, that is the first thing. Next thing is you cannot use dynamic persistent volumes with Fargate nodes. If you are using Fargates like this, if you are using any Fargates like this, you can't use dynamic PB in the sense, right? We have seen storage class. That storage class will create a PB for me as per the requirement of PBC and all. So that is not possible when you are using EFS CSI driver for Fargate. Okay, that is not compatible. And the next one is, version. And remember, dynamic provision requires 1.2 version. So the CSI driver which you are installing, right? The version has to be 1.2 and later. If you are using dynamic static, actually you can use 1.1. That is compatible. Okay. So you can statically provision the volumes using 1.1 of the driver. That is supported. But if you are using dynamic provisioning, you are installing the CSI driver, right? The CSI driver version has to be 1.2 or greater than that. That's how it is. And the version of your driver support is architecture is for ARM64 architecture, you have to use 1.3.2 or later. Right now, we are using AMD 64. We are not using ARM processor. We are using Intel. So I'm not bothered about this particular point, but you have to take into consideration when you are using ARM 64 architecture. Okay, all these are like points that you have to take into consideration before proceeding further. Okay, next one is nothing but prerequisites. Prerequisites are nothing but before doing that particular task, you need to have this particular things to be done. Those are called as prerequisites. Okay, these are the points to remember. Okay, considerations in this sense. Prerequisites in this has to be satisfied before you are going with the next task. Okay, let us see the first one. It is asking us an existing AWS identity open ID connect provider of your cluster has to be enabled. Okay, so for that, if it is not enabled or if you don't know what is happening here, the simple thing is you have to open this document. Okay, and this will let you know whether this is enabled or not. Okay, so let's verify. For that, you can use EKS command or you can use console. Okay, so let me try to use EKS I guess I can execute this command. Let me execute this command first. See this, yeah, let me execute. Oh, my cluster, I have to change the name, right? So here my cluster name is Sudhir-demo, so I have to give that. I think some people are pinging in WhatsApp. Ask them to give them the link, or you can share the meeting invite to them to their email address. Okay. I started the recording, right? So I cannot interrupt in between. So you can see here, this is called as OIDC, Open ID. You can see there. You can see this is called as Open ID Connect. This is like a mediator between your IAM service and your EKS cluster for authentication purpose. Okay. By default, Kubernetes is not having inbuilt authentication feature. It is there, but a few things are not available. So your Kubernetes is taking the help of your AWS IAM service to authenticate. That's how it is. Okay. Now let me cross verify. This is done. Determine whether your IAM IODC provider with your cluster is already in the account. So I can execute this command. If it is not there, I have to do some particular task. Okay. So here, generally what they are trying to say is, first of all, we have to remove this. Now I can copy paste this command. Okay. So what this command is doing is, it is executing this command. Okay, that result is getting stored here. Open ID. Okay, simple thing. What happened? No cluster found. Oh, sorry. Again, repetitively, I'm giving the same issue actually. So I have to rename the. So I need to remove this and add the cluster. Create hyphen. Okay, done. If you want to see the variable details, IOIDC, I underscore ID. You can see that. I by using that command, I pulled only this particular information. That's it. I want this ID. So for that, they have written cut command. I told you what is cut command, right? So this is called as delimiter. Delimiter in the sense, I want to remove this. You can see one, two, three, four. This is fifth. I want to pull this fifth entry. So that's the reason hyphen F5. Okay. So this will pull only this particular entry. That's how it is. Now this information is stored in this variable. Okay. Now if I execute this command, so it is trying to pull that. So I think it is not available actually, but still, let's cross verify. If it is not available, we have to execute this command. It's taking too long. Yeah. So by default, it is available. Okay, you can see the details and all. In your case, if it is not available, we have to execute this command. And remember, this package is not available in your system. You have to install it. For that, you can refer this document, EKS CTL install. When I discussed about ingress controller, I've told you how to install this particular package. Okay, so follow this and try to install. It doesn't take much time and it is not complex. Okay. So once this is done, in my case, I have the result. If see clearly they are saying you that if output is returned from the previous command, then already the provider of your cluster has been integrated. Okay. If you don't see any output, if it is empty output, then you have to execute this command. Okay. So do remember that particular point. So once this is done, this verification is done as part of this prerequisite. What is the next prerequisite? They are trying to say that version or later AWS CLI has to be installed. So let us verify. So AWS hyphen FN version. Now we can see we are using 2.7.30. So it is greater than this, right? So this condition is also satisfied. What is the next one? kubectl has to be installed with at least this particular version, right? So let us cross verify that as well. kubectl hyphen FN version. Sorry. Okay, so kubectl client. I think kubectl client. I think. Sorry. Oh, kubectl hyphen. I can use this particular. -L hybrid kubectl. You can see the version is 1.23.10. That is fine. So all these prerequisites has been satisfied. We have taken into this particular points into consideration as well. Now we are good to go and we have to proceed further. Okay. And do remember, if any one of the condition is not satisfying, you will face a trouble while installing this particular setup. Okay. So do remember this particular point. Now let us try to install the driver. For that, what they are trying to say is they are creating a separate policy for this. So let me execute this command. This command is downloading a JSON file for this particular action, and it is storing in your local system. Okay, so let me copy this, and I think I already have this. So I will create a directory mkdir EFS hyphen EKS. Under this, I will store all the files. Let me execute this one. It is done. The file has been stored. If you try to open this file, you will see these are the permissions what I have. If someone is using this particular policy, they will get these many permissions. What is that? Elastic file system access. I can contact to EC2 as well. Okay. So I'm getting describe access point, describe file system, describe mount targets. So it's kind of read access. That's what I'm trying to do. And this is the IAM policy. Now this policy we are trying to create in our AWS. So right now, if I go to this, see we can create through console or we can create from CLI as well. Okay. That is our choice. So let me go back to here. So I'll go back here, go to IAM. Let me show you in my system. I have in my AWS account, I have this policy on. So I will go to policies. I'll search with a name called. Uh, Let me search with this name. Copy and so this policy was not available by default. I have to create. So you can do it from here as well. But we are trying to do it from CLI. Since we have not seen much about CLI, right? So we can do it now. You can see here AWS IAM is a service. In IAM service, what you want to do? I want to create a policy. What is the name that you want to assign to the policy? And where is the file? That file is in your local system. That's how it is. See, copy this command and let me save it in the notepad. I'll paste it here. This is what we are trying to do. Okay. So let me paste it here as well. Okay. Now we can see this policy has been created. Let me show you how to verify it. So go back to this and search for it. You'll see that policy. Now, let me search. Now we can see it is available. You can see this. Okay. So this is one of the approach. Like from the CLI, we can create a policy. Okay, that is there. Now, create IAM role. Why? Because Kubernetes can talk to other services. Kubernetes is one service. So EKS is one service. Wants to talk to another service, that is Elastic File System. So I need to create a role. There is no other choice for me. So for that role, I have to assign this particular policy what I've created. So either you can execute this command, EKSCTL command, or you can execute this command as well. You can use whatever the approach you want. There is no thumb rule that you have to follow only this particular approach. Okay, either you can use EKSCTL or you can use this particular approach. Any one of them. Okay, so do remember this particular point. So yeah, I have to. What I need to do? Let's see carefully. I'm using AWS CLI. So determine the cluster OIDC provider URL. So as I told you before, we can execute this command to get the OIDC. Let me paste it here so that you can remember these commands. Here I have to replace the cluster name. So where hyphen dev. Let me execute this. Now we can say this is our reference point. Okay, so keep it as it is. We will do it in the next stage. Now this is the output port we got. In your case, it will be different. Why? Because the region and the ID will be different for each and every account, each and every cluster as well. So right now, what it is trying to say, create a IAM role. Okay, granting the Kubernetes service account with this particular action. So you are allowing your Kubernetes to do this particular action. Assume role with web identity. What does it mean is nothing but if you go to roles, okay, and if you try to say create role, this is what it is trying to do. Okay, in this you have to select that OIDC. For example, what is that actually? A11F5. This one. Okay. So instead of you doing from the dashboard, now we are doing from CLI. Okay, that's how it is. Okay, that's how it is. Now if I say next, then you will start attaching the policy and all. Instead of doing from this particular dashboard, I'm doing from CLI. Okay, so simple to understand. Okay, so this is how it is. It is not too complex. Instead of doing from the dashboard, right now I'm doing from CLI. Okay, so what I have to do is I have to create a file first and copy this content. Okay, let me do that. I will say trust policy.json file. I'll create a file called trust hyphen policy.json. And remember, I have to replace the values. So sources, get this particular URL. No need to copy this HTTPS, just copy till here. Open this file and replace wherever you see this. I guess it is here. I have to replace this. Okay, I think I need to copy this one. Major portion is this. So I have to copy this one. And let me open the file. I have to replace. So first I need to do it here. Uh, here actually. Go to the end. Remove this entry. And I have to modify here as well. Yeah, modify here. Okay. So you have to be careful while modifying this file. I'll tell you what to modify. This is done. After that, you have to update here your region. Okay, what is your region where your Kubernetes cluster is running? US East hyphen one. Okay, and here I have to use my account ID. So remove this. I have to give my account ID. Here I can copy this one. That's it. These are the modifications, and one more point is here. I have to modify US East one. Okay. Anything else is missing, which is like federated user, web identity, and this is like okay, fine. Everything seems to be fine. I have replaced all the values. So save this particular file and come out. Okay. Now with this particular policy, I have to create a role. Let me do that. So what's the command? You have to execute this command. Okay. So let me open the notepad and save it here. Okay. So I created with the same name. So that's the reason I can just copy paste it. Okay. You can see I gave the same name. Okay, and this is the role which is getting created. Okay, before creating it, let me show you whether this role exists or not in my dashboard. Go to roles, search for the role. I don't have it right now. Now see, you can see the role has been created successfully. Okay, if you go back to this and if you search for that, let me refresh. You can see now the role is available, and you can see the trust relationship. Okay, this is what you have to do. If you do any mistake here, you'll have lot of issues. Okay, you will be facing some problem in troubleshooting it. Okay, I'll give you the guide as well, how to troubleshoot and all. Let's see if we also face the same issues. I'll show you how to troubleshoot as well. I'm hoping we should get some mistakes so that we can troubleshoot that issues. Okay, let's see. This is done. This job is done right now. So let us proceed with the next step. Now it is asking us to attach the policy which we have created earlier to this particular role. So what we are trying to do now, this particular role doesn't have any permissions. These permissions have to attach. So how to do that? Execute this command. Simple. So this policy I'm attaching to this particular role. Simple. Okay, copy this command because I need to do some modifications. Um, Paste it here. I have to modify the ID, account ID here. So let me get it from here, copy and paste. Done. So copy this one and paste on the CLI. So this is also done. I'm hoping that in our account, if you go and refresh this, now you'll see a policy. Done. Let's see this. Job it is done. Okay, you can see the max session duration. What does it mean? When the session is established, when someone is using this particular role, if the session was created, the session will be expired in 1 hour. Again, the new session has to be created. That is what I've told the STS. Okay, security token service. The expiry date of this particular session is 1 hour max. If I want to modify this parameter, edit, and you can modify here whatever you want to set. Hours or days, whatever you want. Custom value, you can see here. You have to see calculate in seconds. Okay. Enter the custom duration of this 1 to 12 hours, whatever you want. So right now, let it be default value, that is 1 hour, as per best practice. Okay. All the things are done which are necessary for this particular role. Now your Kubernetes is using this particular role to do some actions. Let us see what is that. Okay. Any questions till here? Till here, do you have any questions until this particular point? If you have any questions, let me know. No? Okay, hope everybody understood this. Now, what is the next phase is, I'm creating a Kubernetes service account. Okay, this service account, okay, will be using this particular role. Inside your Kubernetes cluster, one application will be using this particular service account to talk to this particular role. That's how it is. Inside your Kubernetes cluster, one application will take the help of the service account with the name called, this is the name. Okay. This particular service account will help you to use this particular role. So if you take the help of this particular role, you can do the actions what you have specified in this particular policy. Okay. That's how it is. What is that policy? You can contact Elastic File System. You can get the information of file system ID, access point ID, those kind of things. Okay. This file is not there. I have to create it. So EFS hyphen. So let me create like that. EFS hyphen. So EFS hyphen service hyphen account dot YAML because we need to apply in your Kubernetes cluster. That's the reason. Okay. You can see this name is same because I created a role with the same name. You can verify here. I created a role with the same name. Okay. And I have to copy this content, this account ID. So let me do that and replace here. Okay. Now inside your Kubernetes cluster, some application is using this particular service account to take the help of this particular role to contact your Elastic File System. That's how it is. Now let me save this one. I have to apply it. You can see the command as well. How to execute kubectl apply or create. So kubectl create or we can say apply hyphen f EFS. You have to see a successful output. And if you want, you can verify that as well. kubectl get SA hyphen O void. Let me show you. I think it is created in a specific namespace. I think it is cube hyphen system namespace. Yeah, somewhere it is. Okay. Oh my God, I need to give the give some name. I need to search with this particular name. Let me filter. Here you go. You can see this, right? If you want to describe this and if you want to see the details, keep it here. Get service account dash name and then hyphen o YAML in a namespace called q hyphen system namespace. Because in the YAML it is written where to create. Now we can see the details. Always we have to verify this one. This is so important for us. This is our point of contact. Okay. If you have done any mistake here, that will mess up your EFS driver, what you are going to install. That's the reason. So go back to this. Now we are ready to install our Amazon EFS driver. Here there are three approaches. One is Helm charts, manifest, and then private and public. So we will be using public actually. What happened to this? Okay, I will be using public. Okay. So let's scroll down. Here we have to download this particular manifest file. Okay. Mm, manifest. Okay, let me try to access this one actually. Edit the file and let me try to execute this. I hope it will not execute successfully because I need to download a stable release research for this. So this is the reference. If you go to deploy Kubernetes and there deploy Kubernetes overlay stable. So these are the files it will download. Actually. You can see this one, and it will download this ECR, this file as well. Okay, these details you are trying to download it. That's how it is. Okay. What I will do is let me do one thing. Here I have prepared another document to download this. Let me fetch that. Hmm. Let me execute this one. Okay, see what happens to it. But I want to download this one because I want to verify. Okay, anyway, it will download. Let's see. I'm hoping there is some mistake. Let's see. Yes, we have a mistake. Hmm. So release depth is nothing but I have to give the release version. So I'm hoping that we have to give some. Let me cross check how to give this. Just a second. Give me a couple of seconds. EFS CSI driver deployment overlay stable. Let me reference and release version actually. Hmm. Let me go back to this and give something here as master. I'm hoping it should download because we have a master branch. Now this file is available. You can see this one. Open this file. Okay, this is the file what we have. And remember, let us read the document. Okay, what they're trying to say: edit the file and remove the following lines that create a Kubernetes service account. It's not necessary. It is not necessary because the service account was created in the previous step. What is that? You remember, somewhere have created that. Okay, CL. If you go here, I've already created a service account. Again, I should not create it. So they are saying you that please open this particular file and they're asking us remove this particular entry. What is that service account name? EFS CSI controller hyphen SA. We go here. This is the first one. What you see? I need to remove this. Don't remove this one. Controller. You have to see like this, not node. This is node, and this is controller. So which one you have to remove? Controller. Okay. So do understand that. So here I need to remove this enter. cd command. Let's remove this. Okay. Now save this file and come out. Okay. After that, they are trying asking us to apply this. Okay. Just copy paste because we have created with the same name, right? No issues with that. Done. So it will be applied. After that, create a Amazon EFS file system. So we have to do this particular task. Let's see. So now it is doing the job. It is installed. Deprecated 1.4 installed. Okay, it is just a warning. No need to worry too much about it. Okay. Now after this, we have to this one and create Elastic file system. Okay, driver supports Elastic file system access points, which are application specific entry points into the Amazon Elastic file system that makes it easier to share the file system between multiple points. Okay, so that is the purpose of your Elastic file system. You must complete the following steps in the same terminal because variables are set and used across the steps. So what they're trying to do, they are pulling the VPC ID, they're pulling the CIDR range, and they're creating a security group, and they're creating a inbound rules, and then they're creating a file system actually, and they're creating a node, they're fetching the node details, and they're trying to deploy on that particular node. Okay. So what I will do is I'll create Elastic file system from the console itself. Okay, I'll not be using CL. Let me go to EFS, Elastic file system. See, without creating Elastic file system, we cannot use it, right? So that's the reason. Now let me go back. Let's say file system, create file system, Subir hyphen demo. Then let's say I want to launch this particular file system on where my Kubernetes cluster is running. So right now my Kubernetes cluster is running here, EKS hyphen VPC hyphen network hyphen VPC. So let me select that standard, customize, disable backup, disable encryption. Next, VPCs, I want to launch on all the VPCs and I have to select the security group where I want to allow only EFS. I've already created this. Okay, in your case, you have to create if you want to use a separate security group. Let me remove this default ones and select the purple. So these things you already know. I don't need to explain pinpoint. It's fine, and then say next and review. Create. It doesn't take much time to create. Okay. Now here, what they are trying to do is, in order to create Elastic file system, they are fetching these details. But we created from dashboard level, so we are not worried about this. Okay. The final thing is file system is created. That is fine. HTTL get nodes. Create mount targets. So we have to create a mount targets, right? That we have to do. So I'll tell you how to do it. So we have to follow from here because these steps are done from the dashboard. That's the reason. Have to execute this one. Let's how we can see. Okay, mount targets also we have created, right? So I don't need to worry about this one. I'll leave it. Now we have to deploy a sample application and see. Before deploying a sample application, we have deployed our EFS driver, right? Let's verify the status of it. Okay, this is done. So I can close this one. What I mean to say is, we have deployed our EFS CSI driver. Let's verify the status. It is deployed as a daemon set. You can see here. So TCTL get all hyphen O void. I think it is created in which namespace. Let me verify. I'm assuming that it is created in default namespace, or else it might be created in. So it is created in another namespace. So let me verify. In hyphen system. Okay. Now we can see there are so many details. What you have to observe is all the pods has to be in running state, especially your CSI drivers. Where are those actually? Daemon set, AWS not. Here it is. You have to check the status. All you have to do is 3, 3, 3, 3 like this. These pods has to be in running state. Where I can see those pods, here it is. EFS node, node, controller, controller. So we have two pods here. EFS CSI controller, EFS CSI node. Why we have three here? Why we have only two? Why? Because controller is the actual person who will take the request. Okay, when you're creating a PB, the PB will take the request. That request will be picked by your controller, and that controller will give the task to your node. Why we have three? Because it is a daemon set. Daemon set instances, the pod will be running on each and every node, one pod. So how many nodes we have? Three nodes. So CSI node is running on all the three nodes. That's how CSI node pod is running on all the three nodes. Tomorrow, if you add another node, on that node also it will run. Okay. So here controller is running as two pods, but CSI node pod is running as daemon set. This is deployment and this is daemon set. Okay. So these are the two components. If you want to verify it, you can see daemon set. And if you see here, it is deployment 2. Okay. So this is fine. Verification is also done. I just want to see the logs of the CSI driver. Let me just verify because I don't want to see any mistakes. Let's cross verify. I don't know in which namespace it is running. Yeah, cube hyphen system. So by God's grace, we should not see any errors. It is saying me that I have so many pods. Which one you want to see? But let's verify the controller. I don't want to see nodes. Let's try to verify controller. Real log. I want to give this pod and pod name. Again, I have to give this one. Because I have so many containers, it is asking me to give the container details. So I don't have any mistakes. You can see here. Any no errors. That's what I mean to say. The CSI driver was properly integrated to my Kubernetes cluster. Okay, this is done. So kubectl get. So I just want to validate one thing. Okay, fine, no problem. What else we have to do? Anything else? Static and dynamic. This is also done. Yeah. Now we can deploy some sample application and we can verify how your what to say elastic file system is working. Now I will show you a sample application. Then we will deploy Jenkins. Okay, so that you will understand much better. And remember here, dynamic approach, static approach. Dynamic in the sense what? You have to create a storage class, and then the storage class will take the responsibility of creating a PV. That is called as dynamic approach. If you are using Fargate nodes, this dynamic approach provisioning is not supported. Okay. You have to go for static. So let me try to go for static and see how it works. Okay. So I have to clone this particular repo to deploy this sample application. Okay. So let me do that so that I can explain you what is this all about. Yeah, we'll copy the static approach. Okay, clone this. So now we can say this clone. This is the folder. Okay. Now go inside this particular folder so that we can do our testing. Okay, it is asking us now run this command. And remember, you have to fetch the file system ID. Let's see. In this output, you have to get the file system ID. So this is the CLI command where I'm fetching the file system ID. You can go to the browser and you can get it, or else you can execute the CLI command. Okay. Now this ID is important for me. Why? Because I have to open this particular file, edit this particular file and modify. Okay. So I have to go to specs. Under that we have pv.yaml. So take this ID, open this file, and replace this particular yeah volume handle. This is what you have to replace. Done. So volume mode is file system. Access mode is read write many. You know that file system can support network file system, elastic file system, or Azure file system. They support read write mode, read write many mode. So that's what I've discussed last time. And it is using a reclaim policy called retain. You know what is that? And it is creating with a capacity called 5 GB. Your PB is getting created with 5 GB. Okay. So let's see. Now we have to apply this, right? So we have to apply the PB, PBC, and storage class. Let's execute these commands one by one. Remember, before applying this, you have to do your modifications. You have to update your file system ID in a proper way. So do not forget that. Once you're done with that, successfully kubectl get, you have to verify this command. I'll tell you how to verify. First, you have to see a storage class. You can see the storage class has to be created. After that, it is created a PV and PVC. You can see they have to be mounted. You can see they have to be mounted. This is what you have to see. And this particular PVC is using which PV? You can see this one. Okay. So hope you got it. Right now it has created this one. Okay. So I think this is the last one. I think I can delete this. Do I need to EFS file system? Let it be like that. Anyways, no problem. Somehow it got created. That's okay. So what you have to verify is you have to verify this one. Okay. Now let us deploy the pod and see verify the status. Okay. In your case, you will see only two outputs here. This one and you will see this particular output. That's it. Okay. You can see the age. This is 4 days ago. So I can delete this one. Let me delete PV and let me try to delete. Somehow this is still there actually. What happened instead? It is asking me, okay, I have to execute this one. In your case, what you will see is, let me show you once again. Once applying this YAML files, after modifying your pv.yaml file, updating with the file system ID, now you applied the YAML file. What will it will create a storage class, PV and PVC. No, I think it will create only PV. If I'm not wrong. Yeah, it will create only PV, not PVC. You can see the PV, claim, and storage. And you can see volume bind mode is nothing but immediate. It doesn't wait for the pod to be available. If you create a PVC, the PVC immediately it will get attached to your PV. That's how it is. So it doesn't wait for the first customer, means first pod to be created. That's taking such a long time. Okay, why? Because I am hoping that without deleting PVC, you can't delete a PV. So let me delete this one. Delete a PVC, then delete your PV. That is a mistake what I've done. Okay. Now if you look at this, in your case, you have to see the output like this, only this one, and you have to see available status, and you have to see the storage class that has been created. You can see the storage. That's it. Okay, these are the validations what you have to do after applying this particular YAML files. Okay, now what we have to do is, yeah, retain. This is bound. Status bound. How come? Let me verify just a second. Specs, claims. Open this. So it's there. Okay, let me apply this YAML file. Somehow it is missed. What I'm saying actually is I have to create this PVC as well. This is missing actually. Let's reapply this. So you have to verify your storage class. Anyway, one-time verification is enough for that. But here you have to see PV and PVC. Yeah, this is what you have to see actually. One PVC has to be there and one PV has to be there. This PV was attached, this PVC was attached to this PV. You can see the status, EFS-PV. Okay, and the status is bound. That's what you have to verify. So they are telling the same thing here. You have to see the status as bound. After this is done, now you need to deploy some sample application. Let us verify how it is working. Okay, I can apply this YAML file one by one. ctl apply -f specs pod1.yaml and then enter, and I want to apply pod2.yaml. See, these are the code which they have written, someone means like Amazon has written it for testing your Elastic File System functionality. If that is working fine, then I can go ahead and deploy my Jenkins. That's the reason why I want to do this additional step. Actually, it is not needed. Okay. So it is asking us to verify the output, date and time. It is capturing the date and time. So let's verify this. Just you have to execute the command and you have to compare the output. That's it. And app2 here. Both the outputs has to be same. Do understand that. See, if I execute this command again, it will show me the same output. Number of lines. Why? Because it is executing for every 5 seconds. You can see both the results are same. You can see. See, I'm accessing app 1, app 2. Both are showing the same content. How is that possible? Since in the backend, both the pods are using the same PVC. Okay. Do remember the point. Try to recall once again. One PV can be attached to only one PVC. But one PVC can be used by multiple pods. Why? Because it is elastic file system or NFS, whatever it is. That's the reason why it is possible. Why it is? Because we are using read write many. It is not read only many or read write many. Sorry, it is not read only many or read write once. It is read write many. So many in the sense what? Multiple applications can use a single PVC. That's how it is. Right now, this is done. Testing is done. If you want, you can delete, and if you want, you can do a cleanup. And okay, so let me try to delete this. Testing is done. Now I can go and deploy my actual Jenkins and show you how it works. So any questions till here? Any questions? Please let me know. So if you have got confused anything and all. So the only thing is you have to practice once again and come up with the questions if you have. Or else if you have any doubts here now itself, you can ask me. Hope there are no questions. Okay, all the things what I've created got deleted. I've not deleted my last EFS CSI plugin driver action. I deleted only the testing application what I've deployed. Now let us deploy Jenkins. So what I will do is how to deploy Jenkins. I will be using testing purpose. What I will do. Okay, I'll create a PV or okay, I will create a PV. Let it be like that. Okay. And one more thing, what I want to do is I want to create an access point here. Let me do that. I want to create an access point. I don't want to use this file system directly. So what I will do, go to access point. This is a new thing what you are seeing now. Testing is done. So your Elastic file system integration was tested successfully on your Kubernetes cluster. Done. That particular job is done. Now create access point. Let's say Jenkins data store. I want to use this for Jenkins. I want to here do something called Jenkins. Then 1000, 1000, 1000, and here also 1000. I want with that ID 1000 here and 0755. Some people will show you in the demos or somewhere if you refer someone, they'll show you 777. It is not at all needed. Directory should have only 755 permissions as per the best practice. So here I will give name WordPress for Jenkins. So this access point ID is important for me. This ID, access point ID. Let me show you what. Before that, let me try to create a TV first. Okay. So let me take this example. I'll just show you the example. I can use that example as well. Okay. Anyways, let me not bother you too much. Come out of this particular folder. Go to the previous one. Okay. I came back to this particular folder. We are back to our folder actually. Okay. I will create here pv.yaml. Let me insert this. I'll give you this sample YAML file also. Don't need to worry. Here, what I need to do. Here, instead of giving file system ID, I'll give file system ID and then access point ID as well. Both. So how it look? Let me show you. I have to capture properly. If not, it will mess up. So what is your file system ID? Let me search for that first. So this is your file system ID, right? So take this. How will you write this? If you're directly using file system, just have to update this one. Now I'm using file system and access point actually, the reference. So here you have to give two columns here, and then you have to write your access point ID. Let me get this. Okay, take this one. That's how. This is the new thing what you're seeing right. Okay. Rest of the parameters are same what we have seen in the previous example. Access mode read write many. Reclaim policy is written. Storage class is I want to use the storage class what I've already created in the previous step. Okay, and you can see the driver, and this is the volume handle. Okay. Save this particular file, come out. Now let us try to create this YAML file. Okay. So here, create -f pv.yaml. Let us verify the status as kubectl. Sorry, get pv comma pvc. Anyway, pvc is not available, but still I want to see the details at a time. So you can say successfully your pv has been created. Okay, and the status is available, which means that some pvc I can create and they can use it. So I'll create a pvc. So pvc.yaml. The only thing what you have to take into consideration is you have to be careful with the storage class name. Then only this particular PVC will get attached to that particular PV. Do remember this particular point. Now save this. kubectl apply -f pvc.yaml. Anyway, we have to see the bound status. So let us process them. Okay, done. Now let us write a YAML file for Jenkins deployment. Okay. Deployment.yaml. I think I already written some sample file. Let me open that from my GitHub, or let's say Visual Studio. Somewhere in the deployment I have it. Yeah, this is the one. So what I can do is I have this particular YAML file example. Let me take this one. I'll tell you one by one each and every point. Don't worry too much about it. Copy, insert, paste it here. Okay, I want to use only one replica. This is fine, this is fine, this is fine. You know that Jenkins data will be stored here. I'm keeping it in here. Okay, it will be like this. It will be like this. Yeah. Here I don't want to use postpath. Okay, I'm using PVC, right? So let's say how to write this. So refer the official document, or you know that I have already prepared a document. Let's go for storages. PVC first time volume, P1 PVC. So what you write is you have to write like this. Yeah, like this. Right, sir? Yeah. So copy this one. Okay. So what is the PVC name? You have to give that. Let me save this. What's the PVC name right now? EFS hyphen clean. EFS hyphen clean. Now, in the container, your Jenkins important data will be stored here. Okay. And remember, I'm not using host port. Let me remove this one. I'll be creating a service for this. So I want to copy some sample service runner for service. Close this one. See, I'm pulling the data from here and there to satisfy my requirement. Okay. So I have to do like this one. And then paste it here. Here you have to give three hyphens. And here, port number, I want to use something called 8080. Target port is 8080 itself. Why? Because it is Jenkins, right? And what type of service you want to create? Load balancer. And here it is not Jenkins. What is the app name that I give? Jenkins. So this service has to be attached to this particular ports. That's the reason. So here I will say Jenkins. Okay, done. I hope everything should work fine. So close this and let's try to deploy this. Video, create hyphen tutorial. Only 5 minutes I'll take, not more than that. So deploy tutorial get all hyphen O. Why? I want to see all the details like pod details, deployment details, replica set details. And okay, successfully running. You can see load balancer is also created, right? So let me take this one and let us go back to the browser. Okay, and if you try to access this, maybe it is not accessible because your port number is not opened properly. So let's go back to EC2 and check the load balancer security group. I have to verify there whether 8080 port number is opened or not. Scroll down a bit, load balancer. See, this is created by your Kubernetes, not by you. And here, I think it is created a, what do you say, classic load balancer. Let me go to the security group and let me try to open. Oh, which one it is using? This one. So inbound rules, you can see there. Oh, 8080 port number is open from everywhere. Then why it is bothering us? Okay. So let me verify target groups. Ah, create a three instance in services. So out of service there. How come? Why it has not created a target? It's waiting for that. So on the node, you have to open this port number. So do remember, in the security group of your EC2 instances, let's say for example, first you have to verify your worker nodes, what security group they are using. Okay. So here you have to open that particular remote access and inbound rules, you have to open 8080 port number as well. You have to open custom 8080 from anywhere from for now, and you have to open this port number as well. Let us think that this will satisfy our requirement. Or else okay, now we can see in sync. Okay, so I just target page. Three nodes are in sync. Hoping that it can contact my load balancer. From there, it should contact my EC2 instance. So let me check the status of the Jenkins post once again. No issues with the Jenkins, okay? Everything is successfully deployed. Right now, the problem is with the load balancer. Just trying to understand what went wrong here so that I can solve it. Port numbers are fine. It has to work. Try to the same line. Re-execute this command. My bad, guys. I have to give 8080 port number, right? See, when I'm using my load balancer, I gave that it is 8080 port number. So 8080. Now it should start working. Okay, now I got a sign. Thank God. Okay, now I can get a ID from here, password. Okay, continue. I'll show you the data persistence. Okay. Now you can see the plugins are getting installed. I'll just be back in 2 minutes. Just a second. Now let me create a user. Save and continue. You can see the logs found invalid from what it is just a Hadoop error. Found invalid from that is no valid from is included. It is just a warning. That's okay. Not related to this. Hmm. Some filter in the sense. This API tokens. Let me refresh. You have to create. If you want to track this particular logs, you can just give -f and see the live logs. Okay. So that's what are the name? Save and continue. So this is what I'm expecting. Okay, save and finish. You can see it's successfully done. Have to see the login page. Done. Right. So let me create a sample job and let me show you the data persistency demo job. Freestyle project. Let's say okay. Here I just want to run some shell script. So execute shell as usual. Generally I used to do it, right? So ls minus l three, no, three command doesn't work, right? Date command, date command, pwd. That's it. Save. Just I want to show you the data. Okay. This is one thing. Just I want to run the build. Yeah. This is run. I want to run once again, second time. So let me run third time. Then some data has been stored. Okay. Once the Jenkins is deployed. And then I want to go to my manage Jenkins and configure system. Okay, here I want to write some data. This Jenkins dashboard is for production applications workloads deployment. Just I've written like that. Let's say here executors are like 5. That's it. So these are just the modifications we have done. What is this Scrum? That I can see it with. Not too much more than it. Okay, done. Now I'll delete the pod. Okay. A new pod has to be created by your deployment. And once it is done, I should not see it should not show me again from the installation stage. It has to continue from here. I should not lose the data. That's how it is. So what I will do is I'll go back to this and I will delete my form. I'll show you how to. So the simple thing is you can say kubectl scale hyphen replicas equal to 0 deploy slash Jenkins hyphen deploy. Okay. This is simple command. Means the pod will get deleted. Simple thing. If you go back and see, the pod will get deleted. Load balancer will be there. Deployment will be there. Replica set will be there. Nothing will happen to them. You can see there. Nothing has been deleted. Only pods got deleted. You can see the count. Your expectation is 0. Okay. Your expectation is 0. So that's the reason there are no pods. Now let me bring it back. What does it mean? Even though if you delete your pods, nothing will happen to your PV and PVC. Okay. Done. Now let me scale it to 1 again. So which means that new pod will be created. I cannot guarantee that it will launch on the same node. It might be. Okay, if you scroll up a bit, earlier it was launched on which node it is? Yeah, 229.72. Right. Now let us see where it is launched. 229.72. Now where it is launched? It is launched on the same node, unfortunately. Okay, that's okay. That is not our concern. Now if I go back to the load balancer and refresh it, I have to see a login prompt. Okay. This is what I'm expecting. Okay, I should not see that initial admin password, install step plugins, again that XYZ steps and all. So here I have to give the username and password what I give. Password is correct. You can see I've not lost my data. All my 3 pipelines which I've triggered are available. Okay, what are the customizations I've done? Those are also available. I will not lose the data. I'm not losing the data. That's it. That's the benefit of using your Elastic File System. Okay, multiple pods can share the data, and your data will never be lost. You can see I've written this. that is stored. Okay. That's what you need to know. Okay. One more verification how you have to do is log into the any one of the computer. For example, I'll show you how it looks. On which node it is running? Uh, your application is running on 229 somewhere, right? Let me verify it. So go to the 229 here. Okay. So let me log into this particular computer. I'll open this AMD prompt. So this is a verification. Just I want to show you how we can see your mount target. EC2 hyphen. Now if you see df hyphen h command is fine. Okay, let me log in inside the pod. What I will do, you can just again. I just want to show you some verification just a second. Logged into, I just want to log into the pod actually, not into the node. Take the pod IP pod name actually, what is it? Here it is. Exit hyphen ti, enter into this. Once it is successfully done, you can see where you are right now. You are inside the Jenkins pod. Okay. Who am I? Okay. You are inside the container. With the pod. Now if you execute this command, mount pipe grep, I want to see the home directory where it is mounted. So Jenkins underscore home. You can verify this one. Your EFS mounting it is. You can see this. So the container inside the container, this particular directory is mounted to your Elastic file system. You can see this one. This is your Elastic file system actually. You can see this EFS4 RDS dot 4. This same thing you can see here as well, right? If I go to EFS, attach, this is what it is showing you. Where is that local host, something like that, right? Somewhere. Here it will show you. Local host 127.ip. We have seen this one. It will show you like this. Okay. So now what are the data you write here? That will get stored here. That's the benefit. Hope this explanation is more than enough for mounting your Elastic file system to your EKS cluster. Okay. The main purpose is you should not lose the data. Whatever it is, wherever it is running the cluster. Even though in the worst condition, if your cluster is crashed, still my data is stored, my application data is stored in my Elastic file system. That's how it is. Okay. So any questions here? And I think this one as well. Oh, let me the custom data which I've written, right? I just want to show you that verification as well. I've written this right, production Jenkins dashboard. That's how. So I'm done with my task actually. So any questions? Done. So deployment is done. We have seen the integration and all. We can clean up this. Integrate deployment. Sorry, I have to give hyphen. Now any questions? It's almost 1.5 hours. Actually, I thought it is only 1 hour, but still okay. Any concerns or try to practice from your end as well and see how your Elastic file system is getting integrated to your Kubernetes cluster. And do remember, EBS by default is integrated. If you want to integrate some more EBS volumes on from your side, for that also we have EBS CSI Driver. Okay, you can refer this particular document on the right and left hand side panel. You can see this one. This is like if you want to integrate some more EBS volumes to your EKS cluster, then you can refer this document. Okay. Yes, sir.
Sir,
Yeah, something.
sir, in real time, how many days the Jenkins lifetime, sir? Like replica, like
Lifetime.
16 days or 17 days?
See, there is no lifetime for your application. Okay. How long you will need application, you have to put it like this. Okay. If unfortunately your application is down, sorry, if it is lost, you should not lose your data. That's the goal. You will run
Oh,
only one replica. Technically, you will run only one replica. Okay.
oh, okay, sir.
Not more than one for Jenkins. Why? Because one application has to open only one file. Multiple applications cannot open a single file. Why? Because it will apply some lock. Okay. It depends upon the application as well. For Jenkins, we have to run only one replica, not multiple replicas.
Okay, sir.
For Nginx and all, you can test it with multiple replicas, like 2, 3, 4, 5, 6, whatever you want.
Okay, sir.
Any more questions? Okay. That's all for, yeah. Any questions? All right. So yeah, this is all about this integrating this EFS to your EPS. Okay. I will stop the recording.